In lesson 27, we want to multiply and divide some mixed numbers for the first two examples. Now, when we want to multiply or divide mixed numbers, we need to convert them to improper fractions. So let's do that first. For the first example, I'm going to say 2 2/3 would become 2 times 3, which is 6, plus 2, which is 8. 8 over 3 is my improper fraction, times 1 over 7. Now I can look at my numbers, and remember, when I'm multiplying two fractions, I can reduce or cross-reduce. But in these two, I don't see anything that can be reduced. So I simply multiply numerators, 8 times 1, and multiply denominators, 3 times 7. And then I look to see, could I reduce? No, I can't. The answer is 8/21. Let's take a look at example 2. This time I have a whole number, but I don't like that. I'm going to put it over a 1 to make it a fraction. And I'm going to have to convert the second fraction into an improper fraction, or the second mixed number. So I really am going to say 7 over 1 divided by, let's see, 1 times 5 is 5 plus 3 gives me a numerator of 8. The denominator, of course, always stays the same. This is division. I don't divide fractions. Remember, I multiply times the reciprocal. In other words, we flip the second fraction. Once again, we look to see if we can reduce or cross-reduce, but we can't. So we multiply 5 times 7 is 35, 8 times 1 is 8. This problem began with a mixed number, so we're going to convert it back to a mixed number by taking 35 and dividing by 8. That's our improper fraction. I would say 35, 8 goes into 35 4 times. And it gives me a remainder of 3, which I write over my same denominator, which is the divisor also of 8. And my answer is 4 3/8. Now, for example 3, 4, and 5, we're going to deal with addition and subtraction. When we're dealing with addition and subtraction with mixed numbers, we can sort of split them in two. We don't have to convert them to improper fractions. We can sort of deal with the whole number part and then deal with the fraction part, and it makes our math easier. I want to show you that by writing it vertically instead of horizontally. In other words, 5 and 5/8, and then I would say plus 3 and 5/8. Now, I'm going to split it and pretend it's like two problems. I'm just going to add the whole numbers. 5 plus 3 gives me 8. And then I'm going to add the fractions. Well, I've got a common denominator of 8, so all I have to do is put the two numerators in the numerator, and I would say they are 5 plus 5. Well, that's really 10 over 8. And 10 over 8 can be converted into, it's an improper fraction, so it actually becomes a mixed number. Let's see what 10 over 8 becomes when I divide. I say 10 divided by 8. It has the whole number of 1. It has a remainder of 2, which I place over my 8, and then I will reduce it to 1 and 1/4. Remember, I divide both of the numerator and denominator of the fraction by the 2. So what do I do with this 1 and 1/4? It's not my answer. Remember, I've still got the whole number of 8 that I added. So since I was adding, I can now add to my 8, I can add 1 and 1/4. What do I end up with? 9 and 1/4 is my real answer to my problem. Let's look at that a little differently when we do subtraction. Subtraction with mixed numbers, I would say 15 and 4/7. And I'm going to subtract 9 and 11/14. Well, the problem is I don't have a common denominator. For the fractional part, I need a common denominator. So let's translate it. This 15 and 4/7 would be 15 and something over 14. My least common denominator can be 14. Look at both those fractions. How do I get 7 to become 14? Well, I multiply times 2. Now, I don't have to convert the second fraction or mixed number. I can leave it. It's already in 14ths. And I can try my subtraction. But look what happens when I try to subtract 8/14 minus 11/14. I don't have enough 14ths to subtract 11/14. I only have 8. I need to subtract 7. I'm going to have to borrow. So I have this whole number 15. I'll borrow a whole number 1. Now a 1 written as a fraction is really 14 fourteenths. Now I need fourteenths because that's what I'm dealing with. That's my denominator. How many fourteenths does this give me? I now have up here in my first fraction, I have 8 plus 14, which is 22 fourteenths. And I'm going to be subtracting 11 fourteenths for a total of 11 fourteenths in my answer. Okay, that's my fractional answer. What do I do about the whole numbers? Remember the whole numbers back over here. I've still got to subtract. I borrowed from the 15, so I only have 14 minus 9 left. So that gives me a whole number of 5. I'll put those two together for my final answer. My answer is 5 and 11 fourteenths. Let's do it one more time because I know that part is confusing. Let's look at this problem where we have 6 and 4/7, and we're subtracting 5 and 13 fourteenths. Once again, we've got to have a common denominator. Let's fix this fraction. We're only going to deal with the fractional part. We're going to try and leave the whole numbers alone. I need to be fourteenths, so I had to multiply times 2. I'll convert the sevenths. And my number I'm subtracting from is going to be 6 and 8 fourteenths. I'm going to be trying to subtract 5 and 13 fourteenths. Once again, I don't have enough fourteenths in my first number. I need to borrow. If I borrow from a 6, I leave a whole number of 5. What did I borrow? Well, when I borrowed one whole number, it's really the same as 14 fourteenths. So I'll add those fourteenths together. What do I end up with? I'll bring the whole numbers across too so you can see what we're doing. 5 and 22 fourteenths. What am I subtracting? I'm just going to bring this across. I haven't changed anything in the second number. 5 and 13 fourteenths. Now, I can subtract 13 fourteenths from 22 fourteenths, and my answer would be 9 fourteenths. 22 minus 13 would give me 9. So, and then my whole number is 5 minus 5, which is 0. So all I really had left was the fractional answer, 9 over 14.